My name is Richard Ferrer, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired.
Because of Go Cloud Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the GloCloud team.
Welcome, everyone. Today, Alonzo Coleman and I are here, and we're going to talk about which cloud you should learn. Should you learn the AWS cloud first, the Google cloud first, the Azure cloud first, or is there possibly a better way for you to get to your goals? That's going to be the discussion of today's session. So for those of you that don't know me, my name is Mike Gibbs. I'm the CEO of Go Cloud Careers, and I've been every kind of an architect you can imagine. Network architect, business architect, cloud architect, enterprise architect. And I was designing and building clouds for the last 25 years, from the frame relay clouds to the ATM clouds to the BGP clouds to the VPLS clouds to today's modern clouds and private clouds. It's been my life's work. And I love cloud computing and I love all of what I can offer. But today's discussion is which should you learn first? I've been an architect now for over 25 years. My students are now working at Apple, Amazon, Cisco, Google, Microsoft, IBM, Accenture, Deloitte, KPMG, Capgemini, PricewaterhouseCoopers, Barclays Bank, JP Morgan Chase Bank, PNC Bank, and I could give you a lot more, but I think that's probably enough of a list. So I want to show you why and how you should build your career. Before we begin, I wanted to tell everybody that on Thursday, we have a How to Get Your First Cloud Architect Job webinar, and it will teach you what we do as cloud architects, how to become one, and every single skill you need. It's completely free, and we'll spend upwards of 60 to 90 minutes after that answering any technology question you want, completely free on Zoom. So download that or join up for that. And my team has said that today is the last day of our Cyber Monday sale week. I think they extended it today because we got a lot of emails. So 50% off on all our programs today, but only today based upon extending that sale. Now, let's talk about this. Alonzo Coleman is a great cloud architect. He's done some incredible architectures, but he also is our chief marketing officer. And he's got an MBA, and he always looks at this from the perspective of what I need to know to be a cloud architect, the skills that I thought I had before I knew what an architect was, like so many people have, like collecting certifications. And now he's been helping people get hired everywhere. And he's a wonderful resource, and he's got a lot of business background. So Alonzo and I are going to talk about which cloud should you learn? I want to know you're awake. I want to know you're alert. I want to know you're oriented. So let me, maybe in the hash box, give me a hash cloud tag, which cloud to learn in the chat box, and I know you're there. Okay, so let's talk about which cloud you should learn. And I'm going to give you a little bit of statistics before I actually tell you this. What if I told you that 98% of enterprises, which are usually speaking where the biggest and best jobs are and the highest paying jobs are all multi-cloud? And what if I also told you that 89% of all businesses are also multi-cloud? So what does that really mean from the perspective of me as a hiring manager? I can't hire someone that only knows a single cloud. So, Alonzo, Do I have someone learn the cloud, or do I have someone get certified and then try to learn the cloud thereafter? That's a better approach.
Got to learn the cloud. Okay, now let's kind of reel back years ago when I decided I want to get in the cloud. I want to get into the cloud. That looks so freaking cool, but I don't know how. So, I'm listening to the pundits. I'm listening to a lot of different things. And back then, this was a time when everyone was getting AWS certified, rooter to the tutor, all 13, 14 certifications. I said, that must be the cloud that I need to jump into, And I studied. I hit every white paper that they ever produced, try to disseminate what was going on. I clawed my way through some multiple certifications, and I said, I have arrived. I'm here. Let's get into it. And reality slapped me in the face with a reality brick, if you will. And I found out that I wasn't studying the cloud. I was studying services within the cloud, a cloud service provider. Okay, so cloud service provider, they're providing things in the cloud. So I just spent all this time focusing on cloud services and not understanding the competencies of what's important. So reel back, I evaluated what I did. I started learning the cloud itself, understanding what it was, demystifying, and with the help of this gentleman right here, helped me to really streamline and understand what's important, what the cloud is, what services can you use it, and why people are using it in the first place. So learning a cloud service provider is the inverted, unrealistic, and incorrect way to learn about the cloud. You're learning about services. So understanding the fundamentals, it's what's key. Understanding about the presentation layer, the compute layer, the computing layer, database layer, understanding about disaster recovery and all its different forms, from pilot-like to multi-site. What does that mean? Why it's important? Let's talk about networking and how it connects and all its different variations, protocols, and forms. That's cloud architecture. That's cloud computing. That's understanding how everything moves back and forth, in a hybrid multi-cloud environment. So focusing on those competencies is what's important.
Sounds good. So here's what I'm going to do, everyone. I want to actually talk about what you really need to know, and I'm going to describe the main technologies of cloud computing. And I want to ask you all this question. If you wanted to go from point A to point B, and you knew how to drive a car. The first car you got was a Nissan Sentra. That was my first car. What if, something happened to that car, and a year later, 2 years later, you bought a Toyota? Would you need to get certified to drive the Toyota? And then you kept that Toyota for a long time. That Toyota's great. You loved it. And somehow you got a Mercedes next. Would you go and learn another car? Would you have to go back to school? Would you get a whole bunch of certifications? Or would you learn how to drive the car? And, after watching people and asking people that have AWS certifications, in fact, I asked about 1,000 people that were AWS certified, what is cloud computing? And they didn't know. And I asked them what their technologies were in cloud computing, and they didn't know. So if you know cloud computing, you can get any job you want. If you know cloud computing, you can, literally speaking, get any certification you want in a matter of weeks, because you will truly understand cloud computing. So I'm going to talk about a couple of basic things in cloud computing that you need to know. For example, if you're going to be a cloud architect, and I'm going to show you how none of it is actually covered in the certification. But if you actually learn the cloud itself, not only will the certifications be a breeze, but you'll actually be able to do some of the planning and real things that architects actually need to do. So let's talk about the first thing. The cloud is a hosted network and a data center. So I'm going to talk about the things that we have in the data center and the things that we've had in networking for the last 30 years. And I'm going to also talk about those same things in the context of the cloud. Now, when you realize that most of these things are the same things for the last 30 years, the only thing is that the cloud is doing a virtual version of what we used to do, you just tripled your career opportunities. And here's the reason why. You can easily move into enterprise architecture roles by getting a little extra business acumen. You can create private clouds like Nutanix clouds and OpenStack clouds. And when you truly understand the cloud, you can get a job on any cloud you want because you'll understand. But if all you have is certification, the reality is this: even with all 13 AWS certifications, I generally can't hire that person for anything because they still don't have the necessary knowledge to do anything big. They just know a bunch of names. So let's talk about what goes into it. Let's talk about networking. So the first part of cloud computing is networking. Now, the cloud providers run two kinds of networking protocols. They run an interior gateway protocol inside of their autonomous systems, usually OSPF or ISAIS. It's either one of the two. And then they connect their autonomous systems and to external entities via BGP. So the BGP, or the Border Gateway Protocol, is a critical skill for anybody working in cloud computing. Critical skill for a networking person and a traditional data center, critical skill there. Even in the AWS Advanced Networking, it doesn't cover BGP. And for example, what I mean by BGP is you need to understand the BGP protocol, the messages that it sends, the finite state machine, the attributes in BGP, and how you would use or manipulate those attributes to get your traffic to go in a certain direction, how to protect your organization from security risks. And it's not going to be taught in the certification, but if you know BGP, you know a big element of cloud computing. Now, the next component with cloud computing is wide area networking technology. And why do I say this? Because, it's not on-demand access to stuff over the internet. That's silly. You might want to access your cloud environment in a completely secure environment via a wide area network. So it puts us in a different position. So what are the wide area networking technologies that we use in cloud computing and data center computing? We use virtual private lines. So a virtual private line could be an IPsec tunnel, or it could be an SSL TLS-based VPN. But there are differences in the security provided by each of these technologies. For example, an IPsec tunnel in tunnel mode will take the IP header and the payload and encrypt it all, which means that if I send a message to Alonzo, you not only didn't know that what I was sending to Alonzo, you didn't know that Alonzo and I were talking. Now, if I use SSL TLS-based VPNs, it doesn't encrypt the IP headers, it encrypts the payload. So what does that mean? You can see that I'm talking to Alonzo, you just can't see what we're talking about. Maybe I want to combine those two for better security, but either way, just learning how to set up a VPN tunnel or learning how to click the boxes on the certification does not teach you about the security exchanges, the non-repudiation you would get and why you would get non-repudiation, how the message integrity is there. It wouldn't show you how endpoints are verified or even why you would use this technology, but you need to know it. So that's one type of technology you would need as part of cloud computing. It's not covered in cloud certifications, but if you learn the cloud and then you see a virtual version on this cloud, it's going to be silly easy. You'll pass every exam, but you'll also pass the job interview. Now, what about a private line? We've got some on private wires, dedicated connections to the cloud provider. So whether it's an Ethernet private line in the traditional environment, whether it's a tunneled Ethernet over VPLS, whether it is a direct connection to AWS, whether it is an Azure Direct Connect or a direct interconnect with Google, it's the same thing for the last 30 years, minus a few little minor details. So then if you know why you would use a private line and you understand what a private line is and how it works, you understand 100% of all clouds. Now, if you understand network function virtualization, which is where you basically create a software environment of a network, and that network you can create virtual subnets and virtual routers and virtual switches and VLANs. And in that environment, you can put your virtual machines. Guess what? You understand the VPC or the VNet, which is a software-based virtual network, which we've been doing in our data centers. And of course, we do on the cloud. And then if you understand a network function virtualization, does it matter whose cloud provider's VPC or VNet is? No, you already understand it all and then more. Content delivery networks. Another thing, we use this in the cloud and the non-cloud environment. For one thing, they wouldn't teach you in your cloud certification why you might use more than one content delivery network. In fact, they don't even talk about multiple content delivery networks. But if you want, go do an NS lookup of www.amazon.com. And I promise you're going to see they use CloudFront, they use Fastly, I think they use Akamai, or they use so many content delivery networks because they don't want a single point of failure. So what really matters when you select a content delivery network? Of course, none of this is actually in a certification. You have to think about the locations of the caching servers and the capacity that that network has and where their BGP peering points are. For example, Akamai has over 4,000 points of presence where it's got caching servers. AWS has about 400. What does that mean about having 10 times the internet point of presence as if you were going to plan your content delivery network and its performance for your organization? If you want to architect it, you better know this. You can't just say, I'm going to use CloudFront or Akamai without being able to justify your decision. So we need to understand what are the capabilities, what kind of content can we prefresh, what kind of content can we hash, what kind of caching types and hours do we need based upon our traffic. Again, if you know this, you know all clouds. Private data centers too, you can get any job you want anywhere because almost nobody knows this. They know the name of something and how to click it. So let's talk about load balancer type architecture. So in our world, let's say we're in the Middle East and we're trying to block illicit content. We force various countries through a proxy server. And in many cases, a business will need some security things. They want to ban employees from going to certain places, and they use a proxy server. So that is a form of I don't want to call it load balancing, but it kind of is. It's load balancing your internet traffic going out and caching it. But there will be times where you need network load balancers. There will be times where you're going to need application load balancers. And there's going to be times where you need to architecturally put them together to maximize throughput and intelligence. Now, they don't really teach that in a certification. It's more what it is, but you'll need to know that. And when is the load balancer not the right option? When do you use a reverse proxy? And if you're going to use a reverse proxy in a physical environment, it's easy. But what about in a virtual environment? Do you need a load balancer to load balance between virtual machines to create high availability? Again, that's the cloud. If you understand load balancer architectures, you get it all. Now, this gets us into routers, right? Routers, these multi-interface devices that forward traffic. Can't get your traffic from point A to point B on the internet if you don't understand routing. So that goes back into IP addressing, subnetting, supernetting, route aggregation. That gets into BGP, that gets into interior gateway protocols. Again, that's what I'm saying is if you understand routers, when you get to the AWS and you've got the virtual router in your VPC, or you get a transit gateway or any of the equivalents across all cloud providers, it's the same things that we've been dealing with for the last 30 years. And if you know the cloud, and which means you know networking and data center, you can work anywhere, including for the cloud providers for themselves, even building out or designing their data centers if you wanted as an infrastructure architect. Now, let's talk about some other things. So what else is the rest of cloud? We talked about the network, right? So let's talk about the compute. So in cloud computing, we have a few types of compute that we can use. The first kind is virtual machine based. VMware invented the modern hypervisor that we use right now in 1999, which means if you're using a VMware environment in your data center, you're probably using virtual machines. If you're using a Linux hypervisor, like KVM, you're using virtual machines. If you're on AWS and you have a virtual machine called an EC2 instance, you're using a virtual machine. If you go to Azure and it's called an Azure virtual machine, it's the same virtual machine. If you go to Google and they call it compute engine, it's the same virtual machine. So what do you need to understand here? And let me show you, none of what you need to know is covered in the certifications, which is why you need to learn the network and data center, which is why we don't just teach certifications, we teach this. So you need to understand how a type 1 hypervisor works and how the concept of shared tenancy means and what's the risk of a hypervisor attack and and how could hypervisor attacks occur when you figure out where your servers need to be. Now, when it comes to compute performance, we need to think of the single core performance, the multi-core performance for multi-threaded applications, and how that typically works for the applications we need. We need to think about the amount of DRAM that application actually is going to need to have, and what other type of compute accelerators it might need, like a GPU or something like that. And then we need to think about the networking performance of that. Can we use a software-based driver like a traditional virtual machine? Do we need to push a actual PCIe card, for example, into that virtual machine via something like PCI Pathra or the network card like single root IO virtualization? So it's more what you need to know is how these virtual machines work and what they need to be stacked with and how you need to size them as opposed to clicking on the name of a service. But if you know this, you're going to be there. The next thing to think about is we're going to have it in all environments is containers. A little containerized application. So now we need to think when it comes to containers as the control plane, which is what orchestrates it, and then the compute plane or the data plane, which is where it works. So look, all the cloud providers have their proprietary container stuff, like AWS Elastic Container Service. Guess what? It is meaningless in the world of cloud computing today. And here's why we can't use anything like that. In a world of 98% of enterprises using multiple clouds, in a world of 89% of all businesses using multi-cloud, we can't use anything cloud provider proprietary, and that's 50% of the certification stuff. So let's throw out Elastic Container Service. Now that gets us to all the cloud. The only good container orchestration we have left is Kubernetes. Now, could we use an Amazon Kubernetes service, a Google Kubernetes service, or an AWS Elastic Kubernetes service? No, we can't use them either, and here's the reason why. If we are in 3 clouds, and let's say our control plane is in AWS, and we've got a data plane that's sitting in Azure, and then part of our data plane is sitting in Nutanix, and our AWS cloud goes down because of a control plane issue, a network issue, or a hacking issue, now I lost my entire control plane, and I don't have a control plane to run my other clouds. So that doesn't work. So what do we now deal with in all clouds? Kubernetes. So it's actual Kubernetes itself, the standard Kubernetes. And for organizations that want a good managed system, they're going to IBM, they're getting OpenStack, and they're deploying it on all clouds. So there's that. So now let's talk about the next kind of concept we have, the data center and the cloud. Serverless computing. What is serverless computing? It's application hosting, and it runs on, guess what? A server. So what you really need to think about with serverless computing, and whether it's a function in serverless in like a Nutanix or an OpenStack cloud, or whether it is an Azure function or a Lambda function or a Google Cloud function, you really need to be thinking about is, how do you improve that performance? Is the performance good enough? Are we going to have a cold start time? How often are those functions running? Does it make sense to use a function? Does it not make sense to use a function? So all of that is really what matters. None of that's covered in certification. But if you understand those functions, you understand in all clouds. Now, one of the coolest things about cloud computing is auto scaling. What's that mean? Your virtual machines or your containers are getting busy, and you just add additional capacity. No big deal. You can do that in any data center. For example, if you had OpenStack or Nutanix cloud, you could auto scale in your data center. And guess what? You can have them auto scale to the cloud. So again, you're still good. But you need to understand auto scaling. And you need to understand the concept of platform as a service, where it's basically hosted application. And, Microsoft Windows Server has it. VMware has this concept, and you call it like Google App Engine, Azure App Service. All it is application virtualization, and you can learn about that. But if you know application virtualization, guess what? You know it all. So these are really what we're all talking about. And where do you run your virtual machines? You've got a choice on all clouds and all data centers. You either run them in a server-based environment, like a virtual machine or a physical server, or you run them in a serverless, meaning it runs on somebody else's servers and you lose control of it. AWS Fargate, Google Cloud Run, Azure Container Instances, for example. So now let's talk about storage, right? You need to know storage. If you know storage, you know the cloud. So what kind of storage do we have? We have object storage in the data center and the cloud for decades now. And we typically use it for storing documents, images, or videos, serving content, static content for static web pages to a content delivery network, backup on archival purposes, and data lakes. But that's all great and all, but you have to understand the concept of object storage, how object storage works, the way object storage actually uses metadata, the way object storage typically is immutable, and how versions occur. If you know that, you know all clouds. But you won't learn that by clicking a few things and getting a certification, because they don't teach the underlying infrastructure. But it's the underlying infrastructure that you actually need to design things. Same thing with file storage. What kind of file storage would you need? When would you use file storage? How do you improve the performance of file storage? Was managed file storage the right way? Do you need to build your own? Or do you need something that's much higher performance? So that's file storage. And again, it's the same file storage as it was on your Windows PC in 1998 as it is to the storage sitting on your Linux machine and your Mac. Granted, they start in a different format. They format the drives differently, but it's the same. So you need to know file storage. If you know that, you know all clouds. How about block storage, the storage area network that we've been dealing with for the last 20 years? We used to have these little fiber channel cards go into the back of the servers, and then it became fiber channel over Ethernet over an IP network. That kind of storage. that we use for our virtual machines in the cloud and our databases. You understand block storage, you understand every single cloud. I hope you're sensing a theme. All the cloud is a virtualized version of this, but I really want to talk about learning the cloud. And then Alonzo and I are going to have a fun topic about this and discuss it. So what do you need to know in security? Not AWS WAF. You need to understand firewalls, how they work, when to use a firewall, what kind of firewall, when AWS WAF would be good for you versus when should you use a next generation firewall, which is probably 90% of the time for its enhanced security and its enhanced security algorithms. What kind of strategies could you use to prevent data loss prevention across your clouds? How do those data loss prevention systems work? How could they monitor for things leaving the system? What kind of behavior or anomaly-based detection could they use on AI to figure out what's going on? Same thing with your SIEM systems. You got all your logs coming in from everywhere. I'm not going to be looking at CloudWatch logs when I've got three different sets of three different cloud providers. I got to take all that stuff and aggregate it somewhere so we can correlate things from a security perspective. So that puts us into industrial security information event management systems. We're going to be pulling a lot of stuff. So again, we're now big. Identity and access management. I'm not going to play with the cloud providers' identity and access management systems, but I'm going to have some form of federated identity and access management, most likely to our corporate directories. I may have some form of biometric identity and access management. I may be very concerned about the types of identity and access management solutions we could use in hardware, for example, because that's going to be part of my architecture. Again, it's not covered in an AWS advanced security or any of this. This is different. So you have to learn that. But if you learn that, you know the clouds. How about endpoint protection? For example, what do you do on the host? What needs to secure it? For example, what systems needed to be removed? What ports need to be closed? What type of endpoint protection needs to be there? All that stuff, all clouds, you need to know it. You just need to know it. So these are the kind of things we're typically talk about. Incident response planning. Who does what in the event of a security incident? Who speaks to the press? Who goes to the lawyers? Who gets the systems back? Again, we're talking about things that are not really going to be covered. Now, application security, again, something that's going to be critical. For the developers who write their code, what kind of code reviews need to occur? How are the code reviews going to text? What are the secure coding best practices? What kind of things do they need to prevent things like input validation and the stuff? What kind of access controls need to be on that application? How are the APIs between these applications that need to talk to each other being secured? That kind of stuff. Now, we also have to think about governance. And, how do we set up governance? Who needs to lead things? Which stakeholders need to be involved? When a change needs to occur, how is this done? By whom? Who does the impact assessment of that change on the rest of the parts of our systems and our ecosystems? That's what we're talking about. Now, what else are we going to have on the cloud? Databases, right? So we're going to have relational databases, we're going to have NoSQL databases, and we're going to have data warehouses. Okay, now we go back into the world that 98% of enterprises are multi-cloud, 89% of businesses are multi-cloud. So get rid of any cloud providers based database. So no Amazon Aurora, no Google Cloud Bigtable, no Microsoft Cosmos. They're great databases. They are incredible databases. I want to make it clear. Excellent databases. But the problem is I can't run them in 3 different clouds, and everybody is multi-cloud now. So what's that put me in? It puts me into things like Oracle databases or Microsoft SQL or MySQL or MariaDB. You know them, or relational databases. You understand them. If our architects, we don't do SQL queries. We don't touch it. We have to help design it. But the key is if you understand relational databases, you're good. And you'll know all of them, including the cloud providers ones. And you'll even know when to use them and when not. Same thing with NoSQL databases. For example, we have document databases like MongoDB, or of course, Amazon DynamoDB. When would you use something like that versus when we would use a more of a column-friendly store like Apache Cassandra? Or when do we need systems that read at all nodes and can write at all nodes? Apache Cassandra can write at all nodes. So we can think about what those types of things will be, which gets us into big data environments, things like object storage, mapping and reduction functions, extraction, translation, and loading, extract, load, transformation tools, those kind of things. Guess what? If we use the native tools across all clouds, again, it's the same technology. So what I was trying to show you here is you could go through all the AWS and Azure certifications in the world and you still won't know the cloud. Or you could just go and learn the cloud and then know all these things. And then the only thing you need in a certification is a vocabulary tune-up. Okay, this virtual machine's an EC2 instance. Got it, Mike. Okay, it's very simple because you understand it. So, Alonzo, let me go back. I remember your time in the beginning. I remember one of the discussions we had then, and now you could go on for hours. But I remember, you were certified and you had a bunch of certifications, and you asked me about cloud computing, and you said what I needed. And I said, I don't know. Let me ask you. And I asked you about virtual machine sizing and CPU and DRAM of an application. And you had reminded me that wasn't part of your certification. And I said, yes, that's why we're having this conversation today.
Oh, I remember that. I think back a lot every day as a continuous didactic learner to try to just continually push forward. I think back to where I was then and where I was now, and it just goes right back to not looking at a cloud service provider through their lenses and think that that is cloud computing, or that you're only going to use that one type of service across all opportunities for cloud computing. So I like to use this example of, you've got 3 different type of airlines. They're going to take you everywhere you want to go, but they prefer you use theirs because it's more revenue. It's more opportunities for them to say that they did this, that, and the other. But ultimately, you have to understand that that's just a cloud service to get you from point A to point B. Yeah. And what Mike just keeps underscoring is that learn the fundamentals. Don't learn the cloud service providers first. Understand the differences and boil down the difference between block storage, object storage, compute, what it is, VLANs, VLAN trunking, VLAN tagging, 802.1, all of these things, especially BGP. I will be the first to say that networking is not my forte, but it's one of those things where I am compelled to learn it because it's so important and it's intriguing. So when you think about BGP and what it means externally, and how it drives companies and what the overall internet encompasses with BGP, you're going to just have that wow factor. So I'm taking it back to what Mike is saying, is that all, just like any martial arts, you have different ones. Some are close quarter, some can be a little mid, or some uses kicks, some uses punches, some uses arm extensions, whatever it may be. But understanding that it's not one particular martial arts that's going to do everything for everyone. It's a combination of all those, with the foundation of one, understanding what cloud architecture is, or understanding what martial arts is supposed to do. So I just always implore people, get the fundamentals and then fine tune whatever learning you want to do for the particular cloud service provider that is beneficial for that project or multiple projects or that or overall organization.
Yeah, you mentioned martial arts, and Alonzo, you and I are martial artists. So let's talk about this. I want to use a martial arts example to talk about cloud computing. So in my youth, I was the most clumsy person you could possibly imagine. I was the guy that could trip over my feet. It was terrible. And I walked into my first martial arts class as a young man, like 12 years old. And they were trying to show me how to throw a straight punch, a hammer fist, a front kick, and a roundhouse kick. And Alonzo, it took me 9 months to do that. And it was like, they were looking at me, and Sensei was like, what's going on? I said, I don't know why, but somehow I'm learning how to figure out how to learn this movement. He shook his head and he was like, 50 push-ups on your knuckles. So I did my 50 push-ups on my knuckles. And then something happened. One day it started to fit together, and I was there for about a year or two. And then I was interested in another martial art, and they were trying to show how they would block. And I went like that. And they went, good skills, good instincts. And all of a sudden I knew how to move. I didn't know the new way they wanted me to move, but I knew how to move. And poof. Wow, that second martial art was super easy to learn. And then because I never had enough samurai arts when I was younger and I was interested, I learned Filipino martial arts because I wanted to learn swords and those kinds of things and knives. And he did that for a while. And then it was like, here's another blade-based art. And again, it was easy to learn. And the reason that it was all easy to learn, and maybe you had a similar experience, was they weren't that much different.
No.
Once you actually peeled back the onion, you can only punch a certain way. You can only kick in a certain direction. You can only elbow strike in a certain direction or knee strike. And then it's just variation. Are you baiting people into things? Are you a counter striker? Are you a defensive? Are you offensive? And then it's no longer about the art. It's about you and what you can do. So to me, that's architecture. Isn't it the same thing to you?
I think it is. I think it is. You hit the nail on the head about that, Mike, is that all things, just like martial arts, you have Eskrima, you have Arnis, you have Silat, you have Kendo, you have Shotokan, you have all of these things, but there are always going to be overlapping fundamentals of how you can be effective in each discipline. Same thing with cloud architecture, understanding those fundamentals, understanding about computing, networking, databases, security, content delivery networks, all of these things that help that environment not only be highly available, redundant, but you're going to continually understand how to drive for success, just like you drive for performance in your martial arts. It's all relative.
Yeah, and it is. And we will answer questions after we talk about things. And John Doe, especially, I'll get to yours because I come from healthcare. At least 25 years ago, I was practicing internal medicine. So I've helped a lot of people transfer careers, and we will discuss it as well as everyone else's. But the key here to remember is the cloud is just a data center. It's just a network. And if you understand what it is, you can design it. And here's why you have to know. I'll give you a couple of use cases. Somebody literally came to my business, and he told me how he was going to save me money with this. And I said, and he was so excited, this brand new kind of link. It's a wire that's not a wire. I said, yeah, a pseudo wire. He says, isn't it exciting? It's brand new. Our company invented it. And I said, no, actually, I was part of the Martini draft that was done between Cisco, Juniper Networks, Riverstone Networks on how to signal an Ethernet tunnel over an MPLS network 20 some years ago, back in 2001. Oh. Now imagine walking into someone's office saying, I have something new for you. The washing machine. They'd laugh you out of the room. But what happens is when we look at the way the certs are written, they're not teaching the technology. They intentionally hid the technology because if you know when the technology is, you're not going to approach it in the approach of a technician. Click, click, click. When you really understand what the technology is, you approach it the way you should, as a strategist, as a consultant. And what I mean by this, and I'll talk to Alonzo about strategy. He's great at chess and all kinds of strategy. But if we look at where we're going, what is it going to take to get there? What are the sum of all those components that take to get there? And it's not just about the tech. It'll never be about the tech. So if we look at a business and as architects, our job is to improve that business. What are the things that it takes to improve a business? Well, assuming we have a good product that actually solves a person's problem and there's a demand for it. And we have revenue because of that, because people are buying it. But what does it really take? If you're going to improve a business and all I do is put in better tech, I've done nothing. I've literally done nothing in most cases. Alonzo, now you got this cheap pencil, and now I'm going to give you a $200 titanium pencil. Guess what I gave Alonzo? A $200 titanium pencil. Now, probably a great impact weapon in Filipino martial arts or Salat, but other than that, it's just a pencil. It didn't change anything. Now, if I look at a business and I say, okay, what are the people that organization has? What challenges those people have? What could we do to get those people to be more effective by moving obstacles out of their way? And then we approach it is, how does the business operate? How do they do things? How do the employees do their jobs? And then we can approach, how do we optimize how employees do their jobs by also getting rid of weaknesses and challenges they have? Now I can find the right technology that does that. Now we're talking architecture. So that's like I go to Alonzo and I say, I need a car that can drive 250 miles an hour. And he finds me a car that can drive 250 miles an hour. I say, I need to fly from this place to this place. and I need to be able to do it without refueling. And Alonzo will say, how fast do I need to get there? How many people do I need? And you can go and find the right plane that has the ability to hold enough fuel, carry the enough people that I need, and get there at the right speed. But if he didn't know that starting point, he can't pick my airplane out. And I can't walk into a client and say, I got this cool, exciting stuff. The 20 or 30-year-old stuff. They just didn't know that it was 20 or 30-year-old stuff and really didn't think about these things. So I hope it's there. So, and thinking about it. Think about that, Alonzo. Talk strategy. Talk about combining the elements of anything to get it there.
Okay. Yeah. I one of the main things, say for instance, in cloud architecture is you've got companies, you're doing assessments and understand, well, we want this, we want all this, we want these bells and whistles and everything else so that we can do this. And my first question is why? What are your drivers? What do you hope to achieve?
Yeah.
Well, how are you? Where are you now? Where have you been? Where do you want to go? Who's going to be a part of that scenario? What's the market value? Where do you see yourself within the industry? Are you going to be a leader, disruptor? A lot of these factors, because I need to know where my starting point will be. I need to know. It's kind of like the best way to pack is like, okay, are we on vacation? And are we going to be camping up in the mountains, or are we going on the beach? I'm not going to be walking around with board shorts on in 30-degree weather. So I need to make sure that my preparation is there. I need to know that I'm understanding how to get the right people in place to baseline the environment, understand who these SMEs are and how we can evaluate this environment, understand what the bottlenecks are, understand what the opportunities are, what's going to be the overall aggregate alignment for C-suite. What are your expectations? So that I can go around and start preparing and doing what I just said, so that I can drive it from the as is to the to be state. So it takes thought, it takes preparation. You just can't go in there saying, okay, I've arrived, but you're misaligned, you're misinformed, or have no information, and you show up in board shorts in the mountains at 30 degrees.
Yeah. But we also have to evaluate this. Someone talked about why it's important to get a good understanding of the cloud provider's native services. Here's the bigger reason why you shouldn't use them 90% of the time. Why using a cloud provider proprietary thing creates technical debt, how it's going to make it harder for that client, and what is that interoperable service that will work in all clouds that is going to be cheaper, and when it's going to be cheaper in the long run. So if I use a native service, and there's times where it makes sense, what I really have to think about is, what do I lose? What challenges is it going to cause for me later? What's the opportunity cost of using this little shiny object that looks good? When the business grows, where's going to be the pain point? Because the reality is, it's generally not more expensive to use two clouds than it is one. If you have 50 servers, you can put 25 in one cloud and 25 in the other cloud, and it doesn't cost more if you're basically splitting it up. Now, there's some networking places where it changes, but based on your architecture, how you do it, it can usually cost less. And in most cases, the cheapest option is to actually build yourself a private cloud and then burst to the public cloud. That's where it really gets there. And it's not a little cheaper in today's world for the average organization. It could be a lot of cheaper. There are some companies that could literally go to Dell and buy 4 servers with where each one is going to have 384 physical cores, about 8 terabytes of DRAM, and a good NVMe array. They buy 4 of these servers for about $1.2 million. And on the cloud, just using the equivalent that they bought for $1.2 million will cost about $24 million over a 4-year period of time. So for some of my smaller businesses don't have this money, it's easier for me to just get them a good system, smack some hypervisors on it, put something that they can work. And honestly, when they get a little bigger, if the cloud is going to give them that agility they need, and they're willing to pay 2 to 2.5 times more for that agility, push it out to the cloud. And obviously what they can also do with that right now is they can build it cheaper. They can actually create a backup where they use DNS and other forms to redirect traffic from their private cloud to their public cloud. And the public cloud could auto scale out. And that way they can use another cloud for actually disaster recovery. So they're protected in 3 places without spending a lot of money. So there's always a good way to do it. And I'm not saying Data Wrangler, we can't use cloud native services. We can. But what we have to do every time is we have to look and say, okay, what do I get from this? And what do I get from this? What do I lose from this? And what do I lose from this? What are those key things that that business needs that we can lose that'll affect them as least amount as possible, versus what are those things that we need to get out of this? And that's kind of why we're there. And that's why we always have to look at it. And that's why a framework that says, here's how to do your stuff. Here, use managed service, use this, use this. That's about as insane as a surgeon that walks into an auditorium and people and said, every one of you is getting spinal surgery. And they ask why. And you say, because I got a framework that says you do spinal surgery whenever possible for people with back pain. And that's kind of where, so we're pretty much saying the same thing. I don't want you to think that I was taking a different side of it. I'm just saying we have to always look at what do we gain and what do we lose. And for the clients that I work with, they usually lose critical things by going cloud proprietary.
Yeah.
But, you know, I don't work with small businesses. Generally speaking, small businesses don't hire enterprise architects, and they don't hire architects that are going to manage a team of 50 architects. So in those conditions, everything changes. So it's a perspective. So I want to really think about that. Now imagine you know all this technology because you learned the cloud. Now, once you know the technology, you can start thinking how it fits together. You can start thinking about it. For example, you can't design an IP address plan if you don't understand IP addressing. If you don't understand how to design your IP address plan, and that means you don't know, and you also don't know how to design your routing plan, how are you going to get your traffic from point A to point B? And most likely it won't go in the most efficient way. And what is the impact of that suboptimal routing on your application's performance, your user's experience, and what you actually get out of that? So there's that. Now let's talk about the other set of skills. They can not only get you hired on the cloud, but can get you paid an additional $100,000 or more. And let's talk about why. And let's talk about the skills that AI can't do. So everything we talked about before, for the most part, AI can't do the conceptual, put the pieces and parts together. AI can write the code on how to build it. But there's that. But let's talk about the rest of it. The first thing that it always comes back down to in architecture is, what problem are we trying to solve? I have people literally, I get 50 emails a day. I got this new AI, this new technology thing. And I throw it away. I've been working with AI since 2001, and I throw it away because none of them have ever asked me, what challenges do you have? They're all just trying to give me a solution for what? That's the physician going out there in the audience saying, spine surgery, everybody. So there's that. But if people understood which kind of problems to solve, now let's say you've got some business acumen and you've got some industry acumen. Maybe you were a nurse, for example, and all of a sudden you're a cloud architect, but you've been in a hospital for the last 10 years. Do you know the challenges with regards to getting a patient in the hospital? Do you know the challenges that are related to the shortages that exist in that hospital? Do you know the challenges that exist with people finding equipment, specifically nurses spending 25% of their time finding their equipment? Do you understand the workflow on what a doctor does when they come in, how the patient's transferred from one unit to another unit to another unit? Do you understand the pharmaceuticals that that hospital needs and the supply chain that they need to get it? Do you understand which procedures are more profitable to that organization and which ones they lose money on, and what you could do to reach out to more patients coming in for the more profitable things, and which physicians could do that could increase the throughput of more profit to increase the rate of that hospital? Did you know that if you get the patient out of the hospital faster, you earn more because you get paid in by Medicare a certain amount of money, no matter what the treatment is. And if they spend more time in there, you actually get paid less and you can go bankrupt. So they need to get them out. So the reason I'm saying this, if you understood that healthcare industry, now you can start to say, ooh, RFID tagging, finding equipment, this is going to be really good. Okay, we've got a little bit of problems with regards to the input process. We're losing where people are going. How could we track them? People spend 15 minutes describing a macular, papular, patchy rash. Take a photo of it, and it's a better description of it. So we start thinking of where those workloads are. How do we find that gear? How do we get nurses and doctors talking to each other? Now we just made healthcare better. So we need to have that acumen. So for the architect, at least, and honestly, if you want to become a distinguished engineer, you want to become an IT sales rep that's earning $300,000 versus an architect that's earning $300,000, or a distinguished engineer, It all comes down to understanding the client's business and solving these problems. So let's talk about what I mean. It's the ability to evaluate that business's performance, which means you need to understand business inputs like revenue, net income, EBITDA, operating income, free cash flow, and what all those impacts are. You got to be able to look at a balance sheet and a financial statement. Alonzo, I know you had to do that. I know you sure know.
Oh, yeah, it's so important.
And then their cost of capital, right? Because that way we can determine whether they should, lease equipment, buy equipment, and build a private data center, as opposed to their costs in the cloud. So we're starting to look at that. And process engineering, right?
Oh, yeah.
How do we make things better if we don't fix the process?
We've got to look at all those things.
Now I've got $1 billion architecture, and Alonzo's the chief information officer that's going to buy it. Alonzo, what do I need to convince you of before I convince you to spend $1 billion?
I need to know what you've done. I need to know competency. I need to know how you're going to attack the problem. What resources are you going to use? What's been your claim to fame? What's been your track record? I need to know these things if I'm going to spend all this money, because this could make or break the organization. Yeah. So other than my wife and potentially your wife, when it comes to buying shoes, because in their mind, they're excited about when they're going to wear it and where they're going to wear it. And admittedly, I have a toy that I buy just the same way. I just think it in my house and I'm just acquiring it like a squirrel. But for normal business decisions, I always think about what it's going to do for my business. All right. I got two options. I can buy a brand new Mercedes over here, which doesn't help my business at all. Or I could invest into 2 new cameras and a good workstation with 2 NVIDIA H100 GPUs in it, and I can do all kinds of AI stuff on it. That might have a bigger impact on my business, assuming that's the right workflow, but the point is I want to know what I'm going to get out of it. Unless it's fun, like a hobby or a toy, I need to know what the impact of the business is. Absolutely.
So if you learn these and you learn how to sell and you learn how to present and you learn how to lead, let's talk about why it's so good. First, AI can't do any of it, so you can't be replaced. It's not like software engineering, and I love software developers, but AI can do what they do. And that's why I wrote articles for big magazines and business magazines on getting out of those back-end careers, because AI could do it, but AI can't do any of these. Now think about it. Now all of a sudden you understand the network, you understand the data center, you understand the cloud. If a big bank says, come work for us as an enterprise architect, you can do it. If a cloud provider comes and says, work for us as a solution architect, you can do it. If a global retailer comes and reaches you can do it. If you get a little bored of doing this stuff because you've done it for 25 years and now you want to lead an architecture team and now you're the manager of architects, guess what? You've got all these same skills and you can still do it. Want to move into a chief technology role? Get a little more business acumen, a little more executive presence, a little more leadership. Want to move into a chief information officer role? Get a little more business acumen, a little more leadership. Get tired of being the techie after all these years and now you want to be the sales rep? Guess what? A little bit of more polish, a little bit of this, and you've got that. And none of these things can be replaced by AI.
No.
So I think we've got some questions that are out there that I think we should answer. And it can be career questions. They can be other things. Honestly, Alonzo, I know you and I don't care. We just want to help people get to their goals.
Yeah. Fire away, everyone. I think we saw a lot of great ones. So we're looking forward to answering those. From MB Project 22, what is the difference between a cloud security architect and an IAM, identity and access management architect?
Okay, great question. So MB Project 22, I want to draw the difference between IAM and security. Identity and access management is not security. It's and considering it to be, so let's say you wanted to make a sandwich and you put lettuce on the sandwich, tomatoes, cheese, turkey, avocado. You could view the lettuce as one component. That's what IAM is. It's one of about 15 components of security. So security encompasses everything.
Yep.
And identity and access management only includes identity and access management. And what is identity and access management? Who are you? What are you allowed to do from a software perspective? And what can you do? So Alonzo is a good friend of mine. So let's say Alonzo is worried for his safety. And I'm going to show you the difference right now between what the security architect would do versus the IAM architect. Alonzo's worried for his safety. So his rich friend decides to put him on an island that you need a boat to go 50 miles into the ocean to get to. Now, Alonzo's billionaire friend puts a 400-foot wall around every component of him, which means the only way you can get over the ball would actually be to climb through a wall that's got oil and grease on it, making it even harder to get. So you could fall on your way up. But if you manage to get over the wall, there's now a big tunnel of water that's been filled with thousands of sharks in that sterile area so that you get eaten by sharks. And in the event you don't get eaten by sharks, now you've got a bunch of retired Navy SEALs that are armed with machine guns that are told to shoot everything on sight. And then if you finally pass the Navy SEALs, you knock on the door and Alonzo says, "Who is this?" And you say, "It's the attacker." And he says, "You're not allowed in." That's identity and access management knocking at the door. Security means block all that stuff. Identity is just one component. So think about it this way. If nobody ever got to Alonzo's private island, Alonzo couldn't be attacked. If nobody can get over that wall, like our firewall, nobody can be attacked. In a layered environment with security, we typically have things like an intrusion detection, intrusion prevention system. If somebody had the boat to go 50 miles, managed to get over a 400-foot grease wall, and then fell into sharks, that sharks are like the intrusion detection, intrusion prevention system. Now behind that, I've got a bunch of armed Navy SEALs with machine guns that are told to shoot on sight anything that shows up. Now, all of a sudden, I've got another line of defense, another intrusion detection, intrusion prevention system. And by the time they get to the house, Alonzo's house, they knock on the door. So now, let's say I'm trying to visit Alonzo. Alonzo could create a rule that would enable me to come in on, say, a helicopter, and he'd have a helipad. And of course, he'd have armed turrets up there to be able to shoot down anything that was in his airspace that wasn't supposed to be if we were trying to lock him down. And that's what we call defense in depth, when we add multiple layers. So full security includes like encryption of storage. It includes things like key management. It includes crafting the security policy, crafting incident response things, setting up a disaster recovery strategy, for example, designing your demilitarized zones, determining what your organization's application security policy should be, determining what kind of identity and access management. All of that falls in the security architect.
Yeah.
So there's very few jobs for IAM architects. Now, here are the jobs for IAM architects that work. It's not somebody that knows Microsoft Active Directory. We are talking about someone that knows so much of identity and access management strategy. So they know all of the identity and access management platforms, how they can integrate with each other, when you couldn't use something like an iris scan versus a fingerprint, and they know where the weaknesses in those systems are. They know how to fail them open, how to fail them close. They know what kind of things they could do to look for other issues. They know all of the random number, random password, hashing type things that would potentially be there, and understand how to design that in a zero trust strategy where everything is untrusted. That's IAM, and that's really one component of security. So it's a specialty architect. We're a cloud security architect. There's still a specialty architect. Now, which one's going to earn you more money? The security architect. Which one has much more career potential? The security architect. Now, I've got a friend that's a great IAM architect. He's from South Africa. He's awesome, but he has decades of knowledge in how all these weird biometric systems work and all of that. And that's what he's architecting. It's not the stuff that you would think about in CSR. Pretty cool stuff, though.
Yeah, it definitely is. You want to be able to just like cloud architecture, you got to understand the fundamentals. You need to understand what it all means from an agnostic perspective, then hone in on a particular facet of what cloud security would be. IAM, if you want to work on offensive, defensive, whatever it is, just look at the fundamentals and then everything else will fall into place. So that's definitely one of the strategies I would recommend for everyone.
Yeah.
Steph. Hello, Mike and Alonzo. For someone who is going through your enterprise architect training course, there is no need to specialize in cloud domain like security or networking. Am I right?
So Steph, Earnjoy, here's the thing. Enterprise is a specialty of itself. And the key with enterprise architecture is you are focused on the big picture. So by very nature of focusing on the big picture, you can't be focusing on something like security. So here's what I think about as an enterprise architect. I think about going to the client, and I think about truly understanding the vision for their business. That means discussions with the C-suite, plenty of them. It means discussions with key stakeholders. I need to understand that strategy, that company 6 months from now, 1 year from now, 5 years from now, 10 years from now. And if I'm working in a big company or a more strategic, I could be planning out 2 decades from now.
Yeah.
So the next thing I need to think about in enterprise architecture is I got to get deep on business processes, because most technology projects fail. You know, I saw somebody say by 2026, 65% of cloud projects are going to fail because of lack of tech staff. In 2024, 70 to 80% of cloud projects actually fall apart and fail because they provide no business value. It's not going to go up to 65%. It would be great if we could get it down to 65%. The trouble is never getting the tech to work. That works. The problem is choosing the right tech and the business processes. So there is that. So lots of ways you can think about it. So as we think about that and you realize enterprise architecture, now I'm dealing with all my clouds. Somewhere along the line, I'm dealing with all my security companies. I'm dealing with all my server companies. I'm dealing with all my security companies. I'm dealing with multiple content delivery networks, for example. You get the point. It's going to have a lot of other stuff. Now I'm dealing with my data environments. I'm dealing with my AI. I'm dealing with my compute. I'm dealing with my storage. The enterprise architect is very, very, very business oriented. You know, it's your typical put on your Armani suit, get paid good Armani suit money, and go to meetings and manage stakeholders, manage vendors, look at impact analyses of an organization's, build technology roadmaps and strategic roadmaps, creating architecture repositories, maintaining architecture frameworks. So that's what we're talking about in enterprise architecture.
Yeah.
Now, the second you'd be focused on networking deeply, you'd lose focus on the big picture. The second you'd focus too much on security, you lose focus on the big picture. So by very definition, you can't get too deep as an enterprise architect.
You can't. Look at it like this, from a Rubik's cube. Each side represents a competency. Networking, security.
Yep.
And you flip one, it's going to affect everything else. So if you're, and I know everyone has done this, you're excited to get one side, all colors, but everything else on all the other facets are in disarray. So if you focus on just one facet of this environment, you got to understand it's going to affect everything else. So we've got to figure out, you know, if we know the as is state and we want to get it to the to be state, but we need to understand. Let's talk about the efficiency. Let's talk about the optimization. Is everything working correctly? If not, why? Should it be should be not repatriation? Should it be deprecation? Is it improving? Should it stay the same? What do we do with this? So we have to understand from a business perspective how it's affecting what's going on with our workflow processes internally, or customer satisfaction, user experience, and so forth. We need to figure these things out before we start making changes that are not bringing value to the business. So when you focus on cloud like security, it's really, you know, it could be great, but is it going to create more of a bottleneck latency wise by going through all these hoops and stuff with security or networking? Are we creating availability zones too far away from our key market, which creates more latency? We need to think about these things. It has to be strategic. We are at a 10,000 foot view, as opposed to looking at all of these particular details like security and networking. And if, like you said, Mike, as Mike said, we're going to lose focus on the overall environment if we do that.
Yeah. And you know, it's interesting. It was a couple of years ago, I had a friend that would train SWAT officers, and he's in my car, and we're on a side street where there's a bunch of kids that are just playing in and out of the street. And we finally pass all of them. About 2 minutes later, I see an orange ball cross the road, and I slowed down very quickly and stopped. And my friend said, Mike, did you stop for the ball? I said, no, I stopped for the kid that was going to be chasing after the ball. And he said, Mike, I was hoping that was your answer, because that's what we try to teach when we teach people executive protection, large-scale security. See the big picture and look at one thing that was an impact to a security. He was just hoping I did that and didn't stop for the ball, and that's what he was looking to see. But that's really the key here with enterprise architecture. It's what are we doing? Why are we doing it? What should we be doing? And is it the right thing? It's getting rid of all that excitement of, oh, there's the newest shiny object, and saying what's right for our customer. Do you know there are customers that, literally speaking, are going back to the mainframe because it did things better, faster, and cheaper than the cloud?
Yep.
And it's not a minimal amount of expenditure that's going there. It's a lot going back to mainframes. Now, does that mean I think we should go to mainframes for most things? No, because in other things, the data center or the cloud is going to do it better, faster, or cheaper. But when it's not right. When it's the wrong technology, use the right technology, regardless of what it is.
Yeah. I mean, the ultimate goal also, Mike, is like make sure that there's not so much emphasis on FinOps. Make sure that we're not hemorrhaging money, hemorrhaging resources. Let's figure out if this stuff is working efficiency and reallocate as necessary, because our goal is the constant evolution of this environment, not to just keep it the same. So it may not be exciting to get, the attractive new shiny stuff. But again, we could get all the spinning rims and all this other great stuff, but is it practical? Is it giving us business value and all these things? So if the proverbial juice isn't worth the squeeze, we need to have these conversations with leadership. We need to have these conversations with people who are utilizing this technology, that it may be great for them, but overall, it's not great for the business. John Doe, what is required to transition from a non-tech career to the cloud?
That photo of Carl Weathers, that really reminds me of things from a long time ago.
There is no tomorrow.
Of yesterday. Although Predator was pretty awesome in that too. So here's the thing, John Doe. It doesn't matter where you come from. It has no idea what your last job was. Mm-mm. What matters when you move to a new career is the following: that you get the right skills, that you become a master of those critical skills, and that you learn how to create the brand to show other people why they should talk to you. They're really the 3 steps. So I have a webinar on Thursday where I'm going to talk about how people can become an architect. I'm also going to tell you this, John. Don't look at a job description, because 90% of job descriptions are inaccurate. You need to find the role you want, and then you need to get the skills for that role. And that's the biggest mistake people make. For example, let's say I have a cloud architect versus a cloud engineer. And in this environment, I've got a cloud architect that's going to be spending their jobs leading teams, giving presentations, writing architecture documents, building business cases, responding to RFIs, RFPs, RFQs, speaking with the board, managing stakeholders, building architecture teams, leading architecture teams, and creating of architecture document and creation of thought leadership document. For the most part, that's what a cloud architect does. Here's what a cloud engineer does. They build it, which means infrastructure as code, like Terraform. They're installing applications on virtual machines. That means a lot of Linux knowledge. They're also now actually going to be implementing things. So that means good knowledge of the command line that we're dealing with. They're going to be automating with Python. So they're going to have to write Python scripts. They're going to be dealing with some DevOps tools. So they need to understand some DevOps. They're going to be writing Bash shell scripts and Linux and Windows PowerShell scripts. Note when I talk to the architect, they don't do any of that. Mm-hmm. And when I talked about the cloud engineer, they do all of that. And that's the biggest thing we see, John. So, John, what is it, the career that you would like? And we'll talk about it. Because this is the only place that I've seen, and our competition will say, oh, you can be a DevOps engineer, a software engineer, a maintenance person, or sysops person, and an architect in the same course. Now, obviously, after they fail and they spent their $2,000 in their 12 months in that class, they have to come to me, and I still have to teach them cloud computing because they still don't know what the cloud is, because it was taught by somebody that doesn't know what the cloud is, and they don't even know where to begin. So come to the free webinar we have on Thursday. We'll talk about cloud architect jobs. And even if it's not that you want to do, I'm okay with it. I can ask you questions and talk about various things that you can do. But realistically, don't worry about, Arun was a student of ours, and he's going to come and speak to you soon. He went from working at Home Depot in a non-tech role to TELUS. Yvonne Tamba, Coyote, those two went from college students to AWS as their first tech job as an architect. Richard went from MUFG Bank's fraud department, non-tech, to a cloud architect. First job. I mean, it doesn't matter. Daniel Bosu, you can see a video of him on our YouTube channel. He was a 20-year-old kid, got his first job at JP Morgan Chase as a solution architect. And the point is, I could give you example after example. You can get any job you want, but you need the right training, and you need the right interview skills, and you have to also be able to show to the hiring managers you are what they want, which means being able to do this job and do it well, being emotionally intelligent, communicating well. They all want it. They're looking for energy, enthusiasm, and passion, and they're looking for things like willingness to go above and beyond, and how you could be a good team player.
Yeah, and one of the things that I definitely want you to take with you, John Doe, is that a lot of people get caught up with wanting to showcase all the things that they know, all the things that they feel is valuable to their career. But you have to look at it from the hiring manager's perspective. Is it what they want? Is it what that aligns to the role that you want to be? Are you doing things, or do you have the skill set to transition into the career or the role that you see? If you're looking at a lot of LinkedIn roles, and you see people are doing enterprise architecture, cloud security, cloud networking, or what have you, is what they have on their LinkedIn or something peripherally with that, is that aligning with what you have? So if you have tons of engineering experience, tons of developer programming experience, or things like that don't showcase strategic business value and things like that, but it showcases more of the technical side, you need to reevaluate that.
Yeah.
Excuse me. Back to Steph. I have been wondering whether someone who wants to specialize in a particular domain like Gen AI architect should learn Google Cloud, since Google is the best AI ML. What do you think?
First, I don't know that I would agree with you that Google is the best AI ML. I can tell you there's some things that Amazon does better than Google. There's some things Microsoft does better than Google. There's some things a lot of people do better than Google. Google's got some good things. What is the right choice is the one that's right for your client. Guess what? You can do every Google AI certification and you'll still know absolutely nothing about AI. So it goes back to the same thing. What kind of problems are we trying to solve? What does that organization's data look like? Right. What kind of AI models would be appropriate for that organization? Small language model, large language model? How do they train that model? What's necessary to train that model? Can they use a pre-trained model versus a non-pre-trained model? Should we make it something that's bigger and more substantial? Should we use some form of an AI agent for this use case? Is this use case going to be mining through data, so help an organization do a trading application? Is this going to be mining through data to look at fuel or oil price predictions in a market? Could this data could it be mining data to be thinking about international arbitrage and the carry trade, where you could buy something, a currency in one part of the world, resell it in another part of the world at a higher price, and then do that? And that, for example, any of that, this is what you need to learn. Right. You go do all those Google AI certifications from AWS and Azure, and you know what? You're still not going to know anything, because it's not going to teach you how to design it. It's not going to teach you how to size it. It's not going to teach you what you need. Now, Steph, earn dry. If you want to be an AI technician, and you want to be the person that clicks on a bunch of boxes all day long, that engineers tell what to do, and then architects create the plan, engineers build it, and you're just doing clicking stuff, yeah. But if I had a goal of enterprise architecture, I'd be learning enterprise architecture. And if my goal was AI architecture, I'd be learning AI, and I would learn how to build it right. 50% of the stuff is not going to be on the cloud. It's too expensive.
Yeah.
It's going to be substantial. In fact, in many cases, it could be is cheap. It could cost as much per month in the cloud as it would be for you to pay for it one time off of the cloud, depending upon what you're actually renting. So now this is a Learn how to solve your customer's problem career, not learn how to get excited about any vendors.
Yeah,
and I can tell you, there's not a manager in the world that's going to think you're going to learn architecture out of any vendor certification.
No, and it goes right back to what we were saying. And there's so many parallels to the pitfalls that organizations and the industry is falling into, the same way that they did cloud computing. This is the best. Do this. This is the best. And then now that AI is on the scene, this is the best. This is the best. Please don't fall into what's best. Fall into what the business needs. You don't know if, and Mike had laid out a lot of examples, but it's like, okay, if you're dealing with legacy systems, is this going to work via middleware with all of these things? And if so, how is it going to create business value? Is it affordable? Do you know the differences between how CPUs, GPUs, or maybe even TPUs are going to be used in this instance? Is it going to be applicable to this? Is it going to be something affordable? Goes right back to what we were talking about: weighted average cost of capital, affordability, CapEx, OpEx. Yeah. These are the things that we're focused on, and we need to understand how all of this, again, is going to be scalable. Is this going to be something that's going to make or break the business? Is it going to be something that's going to be helpful in 2 to 3 years and on? Because none of the stuff that we're doing is static. However, the approaches to how we utilize business concepts is going to be a constant.
Yeah.
Can you please explain the difference between storage and database? I always seem to get confused about both. That's a good question.
Yes, great question. So, Steph, a database is an application that provides structured storage. So if you look at it, think of an Excel spreadsheet where you've got columns and rows. A database, many of them are structured just like that. So databases are designed for you to put a certain kind of data in it, typically typically in a structured or semi-structured manner, so you can go back and find that information and search that information and obtain insights from that information. Now, storage, we could either be talking about volatile storage like DRAM on a computer, or we could be talking about non-volatile storage, which is storage that will say persist after a reboot, that kind of thing. So that typically brings us into storage, which is typically either going to be block storage, object storage, or file storage. So the reality is I could have a server and the server could have a database on it. And if I'm running the server with the storage that's directly in that server, I have my database running on a server that's actually using file storage. Now, I could also be in a cloud computing environment where my database needs to go on a virtual hard drive because it's not as opposed to a physical hard drive. So in this particular environment, I am using a virtual hard drive, which is a virtual drive coming from block storage, which looks and feels like a local hard drive, but it's actually not. It's block storage. To the server itself, it feels like file storage. But to the architecture of the storage itself, it's actually block storage, accessed over a network. Hope that helps. If not, I'll give you a different perspective of it.
And also, as a part of our development program, you're going to have not only an understanding as we go through live classes on a weekly basis, we also have a library focused on storage, focused on databases that you can always refer back to. And that's going to be yours permanently to have as a part of the asynchronous training at Go Cloud Careers.
Yeah.
The Coder from Above. Mike, the program is amazing, seriously amazing. That's awesome. But there's a lot of work, like literally 3 years of video for 2 hours each to watch. Any strategy to learn faster? I'm spending my nights on this.
So great question here. So there's a couple things. So yes, there's an incredible amount of content, and the more time you have through the content, the better you will get through. So here's what I would say. I would want to tell you to do the exact opposite of what some people are inclined to do. If it's taking you a long time to literally go through the content and truly understand the content, I need you to slow it down a bit. So go through one of those classes, take very good notes on that class. Go to the next thing, take good notes. If I discuss something that you don't know on that class, either find a relevant material in the course or go out there and do it. But I want you to slow it down. I don't want you to say speed it up, because if you speed it up, I already speak too fast. And some people are inclined to do that. And if you speed it up, what's going to happen is you're going to miss all these little details, and they're going to be the most critical details that you actually need to be successful. So I would say slow it down, because if you do it this way, if all of a sudden I'm talking about virtual machines in this architecture and virtual machines in this architecture and virtual machines in this architecture, and for some reason you need to go back to that cloud architecture fundamentals thing and watch that doc and watch that video and read the document, go back and do it, because that's going to make more sense to you than just watching 30 or 40 ones, for example. So that's kind of what I would actually say and suggest. And that's typically when I'm lost or when it's taking me longer to go through something. I have to do what the counterintuitive thing is. So I remember the first 3 times I read probably the best BGP book in the world from Bassam Halabi. What do you call it? BGP. Was it Internet Routing Architecture is what it was. First time I did my usual, read that book in about 4 hours. And I was done and I went,
What did I
so I read it again. And then I got a little more. And then I read it again and it was like, you know what? I got 30%. And then I did what I had to do when I had to learn oxidative and non-oxidative phosphorylation and the electrons that would transfer on that electron transport train from something in my youth, because that killed me. It was like one of those things I just couldn't seem to learn, and I slowed it down. I read a page or 2 or 3. I stopped. I took notes. Then what I actually did, because I wanted to be really crazy, is I explained it to a stuffed animal that was in the house. I didn't have a cat. My wife wasn't home, but I wanted to present it because I thought if I could read it, write it down, and present it to a private audience, because I obviously wasn't going to put it in public because I don't want to show the world what I didn't know. But I made myself an audience, and I did that. And if I couldn't give a good presentation, poof, read it, reread it, did it. And I did this every single way through it. And that got me to the point where in a couple months, I knew more than BGP than 96% of the network engineers that were out there. And that's ultimately why I got hired for BGP roles as a BGP consultant, but it was slowing it down. So that's what I would do. Mm-hmm. And I bet after we slow it down, you're going to find the pattern. Mike did this architecture. He did another one 2 months later that's very similar. Mike did this security architecture, and you know what? He did this one, and they're very similar. And that's what I really want you to find is the patterns that, okay, we did a healthcare institution. Here's our healthcare challenges. Look what we did. You know, we did a banking institution, and look, they have some of the challenges. So look what we did here versus what we didn't do differently. If you do that, it'll master that. And, you know, the truth be told is it's all how much time you have. I mean, there's probably 1,000 hours of materials there. So if you had 40 hours a week, that's 2,000 hours a year. If you have 20 hours a week, that implies finishing in, say, 12 months. Now, I'll also say that most people have never finished the program, meaning they've got hired before they actually completed all of it in most cases, because the content was so ridiculously thorough and extensive, because we don't want to leave any chances why people shouldn't get hired. But keep at it. Keep at it and try to make sure you understand it, learn it. You can explain it to a family member. Understand it, learn it. My cat Cindy's not the best person for me to present to when my wife's away, but now I just reached somebody on my team. But please try that. I think it's going to help you so much.
Yeah, repetition is key. If you're working out, you want bigger arms, more reps. If you want to run longer, more time out there on the pavement, on the treadmill, whatever it is.
Yeah,
you got to push yourself. You know, this is one of the things that I want everyone to understand is that if you want the big bucks, it's going to require sacrifice. It's going to require more repetition. It's going to require you to push the envelope, to be able to do peer-related reviews. When you're a part of the program, you're going to have a lot of peers that you can measure yourself against. Iron sharpens iron in any scenario. So we want you to continually focus on, like, okay. And also one of the things I want you to focus on and understand is that if you're good and competent enough, you're able to communicate the value of this concept, not only to Mike, but also to your mom or to your relative or to anyone, even a 6-year-old, and they can understand that. Stop. Focus on what you're not very good at. Focus on the things that you could be stronger in, and continually be repetitious in that so that you can round out your competency. So when we get to the point and say, okay, let's start asking this person some questions, and then we can vet and see that, okay, Mike, do you agree that they're ready to move on and start interviewing? Okay, that's when we'll start helping you in those next phases with your resume, with your LinkedIn profile, with your interview mock training and things like that. So like Mike said, continually focus through repetition on those key points that might be a little challenging for you, and everything else will fall into place.
Yeah.
John Smith, imagining a company as multi-cloud, what tools might be used to help orchestrate the different cloud vendors working together? I'll share something, please.
So let's actually think about a big picture. Multi-cloud is multi-data center. It's the same thing we've been doing for the last 30 years.
Mm-hmm.
So let that sink in. So we could put Nutanix servers in all clouds and use the same control plane. We could put VMware servers in all clouds and control plane. We could just use the virtual machines and the storage, and there's pretty much not a whole heck of a lot that's going on. We can still launch a multi-cloud architecture with Terraform, the engineers that do it. So there's not a lot there. Now let's think about what we do in multi-cloud. We don't use any of those cloud providers' native tools. We use much bigger and more industrial tools. So instead of using AWS WAF, I use a Checkpoint firewall or a Palo Alto firewall or a Fortinet firewall. And I'll tell you why. Here's what happens with AWS WAF. It protects your system from all, it blocks all incoming traffic except that you will explicitly permit, and it provides application layer filtering. Great, right? Now, what happens when a new attack occurs that nobody has ever seen before? It goes right through that AWS WAF firewall and you're hacked. Now, by comparison, if I have a Palo Alto firewall or a Checkpoint firewall or a Cisco firewall or a Fortinet firewall, it does all that same thing that WAF does, AWS WAF, where it blocks all incoming traffic except that's allowed explicitly in. But now I got something else. Now, all of a sudden, how the hacker starts sending some packets to the server that don't look right, and the firewall says, how the hacker? No way, and it writes an ACL on demand, or it resets a TCP connection. Now, by using the Palo Alto tool, guess what? I now have better protection on all my clouds. So I could use Palo Alto things to manage my Palo Alto things, or I could buy an enterprise security, an enterprise systems management tool. The same kind of tools that we were using since the HP OpenView days that can enable us to look at our servers, look at our network, look at our storage, and there's all kinds of big tools that enterprises are using. We use the same ones we've used for multi-data center, and we have no problem. Same thing as we've done for the last 30 years. You're muted, Alonzo.
Also agreed. Keep in mind that no two architects are ever going to be, our architecture environment is ever going to be the same. So you go back and ask that leadership, what are you guys trying to achieve? And what's the environment? Are we legacy? What are we doing here? What does it look like? So a lot of what Mike is saying is going to be dependent on what the goals are, what the environment is, and how we decide to go about it strategically. At the end of the day, bar none, the companies want to make money. How do they do that? By strategically creating phased environments or phased wins to be agile, to be scalable, and so forth, so that they can achieve these goals strategically that creates business value. They want to make money. How do we do it? Be strategic. So always keep in mind that how these tools are used to orchestrate these different cloud vendors depends on a lot of what they're trying to achieve, what their environments are, and how they want to go about doing it.
Mm-hmm.
Wayne, what level of networking certification would you recommend for general cloud architect? This is to networking guru here.
Yeah. So Wayne, so first the question is, would I still recommend a Cisco certification for a network architect? And the answer is, it depends what they want to do. If I would recommend a certification, I would say the Cisco Certified Network Professional, because that's the part where they start to actually teach some networking in there. The CCNA, which is a nice, good networking technician certification, is there. But at the CCNP level, they start to get into the routing protocols to a degree, and they start to talk about it. So if I'm dealing with an architect, I'm going to really look at what I should give them. If it's a cloud architect, I want one cloud provider architect certification, and I know there's zero architecture in it. But it still looks good to say architect certified by the vendor. So either an Azure Solutions Architect Expert or say an AWS Solutions Architect Professional. Now, because they are so damaging in covering no architecture whatsoever, I typically in today's world like something like a TOGAF. And that's an architectural framework, and it's going to show that you know better than trying to use a well-architected framework, which is making recommendations without even knowing the problem, which is why 70 to 80% of cloud architectures fail. So I like those two. And then I start thinking, what's going to be better for my clients long-term? CCNP or CISSP? And when I actually look at the two, and I look at which is harder, the CCNP versus the CISSP, the CCNP is going to be harder than the CISSP. When I look at where the bigger demand is right now in terms of shortages, people, with a global cybersecurity shortage of 4.7 million people, it's so bad that the World Economic Forum is actually figuring out the impact on the economy. And I made a video on this today. So Tyrone, pop a link to my video in the chat box. I say now, for my third certification, and I don't get more than 3 certifications for architects or any professionals, and potentially 4, and I can talk about when that would be and where it would be. Am I better with the CISSP versus the CCNP?
Right.
In a private cloud, probably the CCNP. In the public cloud, probably the CISSP. So that's probably my preferred cloud architect certification. Of course, when you're our students, you have access to all of it, all included in your training. But I'd probably get the knowledge between the CCNA and CCNP, because that's going to be minimum knowledge, and you have access to that anyway. You actually have access to some CCI level knowledge in your training as well. And that's all of what you need and none of what you don't need on that. And I'd probably do the CISSP. Now, if I really wanted to do something on the networking side, I'd do the CCNP or higher. And I love networking. And, I've been in networking forever. My CCI number is 7417. Networking is my love. So I get it. And if you love networking, that's okay too.
Vera, is understanding cloud security a good foundation for cloud architecture, or do you need to learn cloud architecture before cloud security? Shaking out the egg, Mike.
Well, Vera, where are your goals? If your goal is to become a security architect on and off the cloud, I start straight with security architecture. And in there, I learn the underlying things. If my goal is to be a cloud architect, I have to learn cloud architecture. So if I start thinking about an architecture, what goes on, Vera? Some of it's networking, some of it's compute, some of it's storage, some of it's big data, some of it could be databases, some of it are applications, some of it is security, and some of it is going to be AI, and some of it's going to be applications. So it's going to be everything. So cloud security, by comparison, is or cloud architecture is everything. Whether it be 200 different applications you're going to be dealing with and your 3 clouds. So what you have to learn there is cloud architecture, because security is only going to be 1/10 of what you need to know. Now, by comparison, if my goal was to be a cloud security architect, I would get some pretty good knowledge on security. And here I would learn application security, network security, encryption. I get into understanding how to secure applications, securing hosts, securing networks, how to write a security policy, how you manage keys, the types of encryption they could use, encryption selection that you could use. And I love teaching this stuff. I'll be there. Now, Vera, it's almost funny that when we taught the CCSP boot camp, and that's a cybersecurity certification, it's one of my top 3. We did it for free on our YouTube channel. Feel free to get it. Tyrone from my team, drop a link to that in the chat box. I actually think there's more information on cloud computing in the CCSP than the AWS Solutions Architect Professional, which is terrifyingly scary. Because at least here they talk about the compute, they talk about the storage, they talk about the applications, they talk about the cloud challenges. To a greater degree than you would actually get in an AWS certification, which is based on systems administration. Click, click, click here. Here's the new name of something. Here's the exciting reasons why it's exciting. Here's how to do the all AWS, touching AWS without regard to how it fits into the outside world. So there's that. So that would help you, but actually they're different. I'd love you to attend our webinar on Thursday on how to become a cloud architect. And I've trained a lot of security architects both in this program, and I've got a lot of other security things I've done in my life that we can talk about, so that I'm excited about. So come to that free webinar. It's free. And with that way I can ask you questions and you could respond.
Revelation. You talk about building the foundation first. I've been to your website. Where does a newbie start from?
Relevation TV. Every one of our programs starts at ground zero. That is the foundation. I assume everyone knows nothing. And I'm going to do this, and I'm going to answer very shortly. I'm going to answer a senior network engineer, and I'm going to show the difference between engineering and architecture. I love engineers. They build the world. They are awesome, awesome, awesome. But if somebody's been an engineer for 20 years, I bet you they don't even know where to begin on the architect side without learning it. The same way a nurse for 20 years has an incredible degree of healthcare knowledge. But if they had to perform surgery, they wouldn't know where to begin because it is a different job. Both equally important. I'm not saying one's more important than the other. They're not. They're just different. So if you take any of our programs, our cloud architect program, our AI architect program, our enterprise architect program, you know what we do? First, we have an intro to technology section. And that explains at a high level all of the things in cloud computing. What is the cloud? How does the cloud work? Then we do a deep dive after that where we explain every little element of the cloud in a good enough depth that you could pass an interview. And then after that, we show you some architectures and how the pieces and parts actually fit together in an architecture. And then after that, now we start talking about, put you in a group of architectures and you see these architectures and you see them put together, and your professional development training, including your business skills, your leadership skills, your sales skills, your executive skills, all of those things are going to be covered as you're going through the program. And of course, you'll have your hands-on things too. But you'll be in classes 3 times per week, and in classes we'll be designing architecture together. I will divide you guys on architecture projects. For example, because Netflix had a hard time delivering video for the Mike Tyson fight, and because I've been an IP video architect for the last 30 years, since Netflix couldn't do it, I made it my students' business to be able to understand how they would design an architecture that would work for video streaming for 70 million users. That's what they're doing right now. So they're going to be presenting those architectures back to me because all my students could do it. I know how to do it. I can make it easily done. And all my students by the end of this will know how to do it. Mm-hmm. And that way, when you work on these kind of big things and all these little big things start to connect all these weird dots all over the place, that's how you learn how to design. And of course, my students will present it back. They'll document it. They'll have to sell it to me. They live the real job. So they do these things. So what we do is we do live training 3 days per week. We come to class. We work on architectures. You give presentations. I practice interview you. Any kind of cool stuff that we do. Anything necessary to build you there. But all of our programs, the Cloud Architect program, start from the beginning to be a cloud architect. Enterprise Architect program starts from ground zero as an enterprise architect. AI architect assumes you know nothing and you're there. And I have to do that because I love engineers, but you could be an engineer for 20 years. And it's about as different going from the person that fixes the engines on an airplane to flying the plane. Both are important, both very valuable, but a completely different set of skills.
Yeah, definitely helps with eliminating the gap analysis. Like Mike is, we don't know what you know. We don't know what you don't know. And we don't know what the minutiae is about what we hold as a standard versus what you've experienced. So we want to make sure everyone has that single pane of glass to understand how we train, what we look for, what you're going to know, and how you get out there and understand that what you're doing in here, you're going to be doing out there.
Yeah.
Jose, how can a senior network engineer with Cisco ACI and network automation experience transition into a multi-cloud AI architect role?
Jose, I'm going to first show you the difference between engineering and architecture. Of all the engineers out there, the network engineers have the easiest time transitioning into architect roles. But I'm going to show you that it's not related to what you've been doing and how you're going to get there. And I'm going to make it very clear. So the first thing that I would need you to understand is if I were to ask you right now, let's say you've been a network engineer for 20 years, that an organization has a weighted average cost of capital rate of 7.9%, how would you use that information to determine whether they should build a new Nutanix cloud or an OpenStack cloud versus using an AWS or an Azure or a Google cloud? Like how you would figure that out. If I were to ask you how you could create a business case to show the client why they should, to show an internet service provider why why they should accept your $1 billion edge routing proposal, where, for example, you're upgrading the edge switches to a high performance aggregation switch that could deliver various new services to their clients. So focusing on what those services are and the revenue that those services can then enable that internet service provider. Would you know how to go in front of the C-suite and convince them to spend $500 million? Because you will as an architect. Do you know how to do an executive briefing? So I'll bring it back to network architecture to show the difference. If I asked you to design, and you're going to be great, you're going to be fine. I just want to show you the difference between engineering and architecture. If I asked you to design a company's network, and I said they were going to have 5,000 remote locations, they were going to have 100,000 servers, and they were going to need 12 different ISP connections, and they're going to need to run IBGP across their core. Could you design the IP addressing plan? Could you design the routing plan? Could you determine where the aggregation points need to be? Could you properly engineer your traffic? Could you reduce downtime to a certain percentage? Could you create the change management strategy? That's architecture. So if you know how to do these skills right now, you're going to be great. If you don't, you need to learn these skills. How do I design my cloud-wide area network? When and where do I use? How do I deal with the non-transitive routing inside of the cloud provider? What are the route reflector like workarounds we have in the cloud provider to make this work? How do we lock down our end systems? What is an end-to-end security policy? What is a compute policy? So Jose, what you need to go is you need to go from a systems builder and think about how to become a systems designer. It's why on the CCDE, they don't have a lab. Like the CCI lab, what I did was this miserable 2-day lab many years ago when I did it, and you had the first day and the second day of configuration. So start looking at that. What's different in Bassam Halabi's book, Internet Routing Architectures, than what's in the more modern things on how to configure? How do you scale your peering sessions? So join us in the webinar on Thursday, and I'm going to show you. Now, I've taken in a tremendous number of CCIEs, and they've left my program with really good architect jobs. And it doesn't take that long in general. So now, if you have an MBA already, you probably have a lot of these skills that I'm referring to the business side. If you don't, you need to get them. Even at Cisco, Jose, when I was already working there in a solution architect type role, in order to move into an executive architect role, I had to do all these things. So that's typically where we're coming from. So we have to remember architecture, big picture. Architecture is about aligning the organization's people, processes, and technology. Architecture is building an architecture team that's going to be designing these various things. Architecture is about changing all elements of that business, their future vision of the business, their future optimized business processes, and the technology systems that support it. Architecture is about managing 50, 100, 1,000 vendors. Architecture is managing the stakeholders. Architecture is creating the architectural documents and the architectural repository and managing the architecture artifacts that are given to you by your audience. It's about taking that information and showing it to the C-suite and getting their buy-in and getting to support the cultural changes that are necessary to roll out new technology. Jose, this is the best job in the world. And, I remember when I was early into my CCIE days back in 2000, I remember, Mike, you need to come in, you need to make changes in these core routers at 2:00 in the morning. I'm sure you've been there. And this is a job where it's so much easier. So much easier to get things done. I kind of hope that helps.
Ponce. Hi, Mike. With the recent AWS reInvent showcasing new and upgrading services, would you say this highlights AWS's ability to deliver more value to customers compared to GCP and Azure?
So Ponce, David Lithicum and I actually did a 2-hour review of all the AWS things. Now, David Lithicum was Deloitte's head cloud strategist, chief cloud architect. All in all, here's what AWS delivered. Our proprietary stuff that you can't use, here's some extra features. We've now added a few different levels of virtual machines that can compete better with the kind of things that you could buy in the data center. And they created their own large language model along with, probably 15 to 30 other ones that are out there. So all in all, Ponce, I would say the AWS reInvent was a completely underwhelming marketing conference. that if you actually realized all the things they were talking about, it's like, yeah, great. 20 years ago, I did that. Yep, great. 20 years ago, I did that. So it was almost like our cloud is catching up to what we used to be able to use. So no, I don't see additional value over GCP as Azure. But it almost was like Microsoft has their LLM, Google has their LLM. Wow, we finally have one too. Google had systems that were optimized with tensor cores for machine learning. Guess what? Now we've got something that's sort of optimized too. Now it's not going to perform as well as the NVIDIA H100s. And we even had to train the data for these AI services on NVIDIA GPUs because they're better. But here's something that's not going to cost as much as NVIDIA. So no, I think it was a reasonable conference. I mean, I don't think there's anything negative. But if you really look into it from the perspective of an architect, from the perspective of a chief information officer, from the perspective of a chief technology officer, you're going home and you're saying, okay, got it. Azure, got it. Google, got it. Okay, you're all doing the same things. It's the same cloud, same services. The only thing you changed is the names. So no, I don't think it shows anything like that. I think it just shows that a couple of things. One is the better compute performance, and some of the cheaper compute offerings, some of these ARM-based offerings, realized that it cost too much in the cloud versus the data center, so they tried some lower cost offerings. Realizing how much cheaper it is to do heavy AI in the data center by buying your own NVIDIA stuff, if that's what you need. AWS realized the cloud repatriation movement of leaving the cloud was getting there, which is great for cloud architects. We just design private clouds. We don't care. But, going there, they were trying to stave that off. So I don't see leadership. I see trying to make it work, dealing with the economic realities of the cloud costing too much money, and dealing with the economic realities of the cloud repatriation movement, and saying, yep, we're going to try and keep growing with you and what everybody else is doing.
Revelation, how long is your live cloud architect program?
So Relevation, it's until you're hired. So you've got a year in the live classes and unlimited in the live classes. I'll tell you on average, it's about 8 to 12 months in a normal economy for the average user. But the reason I say it's till you're hired, because let's say you buy our program and for some reason you're a little stuck, and then you have a family member that's got something, you need to take care of a family member. And then all of a sudden you've lost 6 months. You come back, you finish, you win, and you get hired. I don't want to kick anybody out. I hate the way boot camps do business. Boot camps, they take people in, they keep you in for 16 months or 6 months, and when they're done, they're not hired. And when they're not hired, they're not working, they're losing their skills, and they're getting worse and worse each day, having it hard to get hired until ultimately somebody comes to us and we retrain them with the right skills anyway. So our program is about 8 to 12 months, but until you get hired. And if you need it longer, we don't care. We just want you to make sure you're hired. I want to know that the only reason you don't get hired if you take our program is because you didn't do the work or you didn't finish the work. Because we're going to let you stay here and keep coming and keep getting better until you're hired. Because that's all I care. Because my people, anybody that comes to us has a good life and a good outcome.
Okay, so I think Panchi, if so, don't you think that indicates that cloud learners should prioritize focusing on AWS for their skill development?
Panchi, I encourage you to go back and watch this, where we showed you could get the AWS Solutions Architect Professional and every AWS certification and still not know anything about cloud computing. We talked about what was covered in these certifications and why it's not sufficient, why it will not teach you any of the knowledge that you actually need. Which is why when we get people with 6 and 7 AWS certifications and we ask them about cloud computing, they don't know where to begin because they don't even know what the cloud is. So no, I need you to learn a lot more than the name of a service and how to configure that. For example, if you want to be an architect, you're not going to be allowed to configure the technology anyway. It's not your job, it's somebody else's. Now, if you wanted to be an admin, you will be configuring the technology. If you wanted to be an engineer, let's talk about all the other 30 or 40 sets of things that you need to learn outside of AWS to work on the cloud. So no, I think you should prioritize learning the cloud. And I can tell you, after watching thousands of others making mistakes, I can tell you that it's all because they tried to learn a single cloud and didn't learn the cloud. And at the end of the day, with 98% of enterprises being multi-cloud and 89% of businesses being multi-cloud, If you only know one, if somebody only knows one cloud, there's no job I could potentially give them. The only time I could ever hire somebody would be if I was the cloud provider themselves trying to hire somebody, because they're the only time when a single cloud would ever be good enough in most modern cases, at least 9 out of 10 times. And in some cases, 9.8 out of 10 times.
Take it from me, Punchy. Do not do that. You will compound, multiply your time of learning, your competency in ways that will cost you, when you think about how much cloud architects, depending on even the role, what they get per year, you multiply an hourly rate times 2080, which is the normal hourly amount of work that you do on an annual basis, and you break that down, you will be furious in how much time that you waste by focusing on the cloud service providers first and not focusing on the foundations of understanding agnostic cloud second. Okay, so avoid what I did. I learned the hard way, and I can't underscore that enough. So please, foundational agnostic first, focusing on cloud service providers later. MB Project 22, is it possible to complete the non-live program in 3 to 4 months?
So MB Project, yes, I've had lots of people finish the project in 3 or 4 months. Now I'm going to tell you this. It would be a lot easier to finish the live program in 4 months than it would be in the non-live program. Because the biggest challenge in getting hired is going to be how well you can deliver a presentation, how well you can deliver that interview, how well you can sell that architecture, and how well you can design that architecture. And if you're in the live class, you're going to be coached on all these things, where if you're in the non-live, you're going to watch other students being coached, even though you'll be given the same content. So generally speaking, it's much easier to get through the live program than the non-live program. Could it be done in 3 months? Delray Bat was hired within 3 months by AWS. Richard O was hired by AWS in 3 months. Daniel Bosu, who took this horrible $35,000 cloud boot camp that didn't know anything about cloud, came to us. He wasted 3 months getting solution architect professional certification. In that class, he said, I'm ready to be hired. I got your certifications. And I said, okay, Daniel, what's cloud computing? Describe this virtual machine to me. Describe the storage area network. Describe this. And he's like, it's just as bad as when I didn't know before. And I said, I know. Now forget everything you learned in those certifications and let's teach you how to be an architect. And about 4 months later, he was hired by Jamie Morgan Chase. And he didn't even graduate high school. So the answer is yes, it could be done. There's 1,000 hours in there. If you were like me when I did my CCIA and I studied 16 hours a day, 6 days a week, yeah, it's about 10 weeks to get through the program. The question is, could you actually remember it that fast?
Yeah.
And maybe you could. Some people can learn that fast, some people couldn't. But it's not out of the realm of possibilities. But I don't like to tell people, yeah, that it's going to be done in 3 to 4 months. Some people can do it, but I think it's more 8 to 12 months for most people.
And here's
the reason.
Go ahead, Mike.
So the average architect earns between $150 and $250 a year. So I want you to understand how much you need to know to be able to get paid more. A really good architect, and then Alonzo will add to this, can easily earn $500,000 a year, which in many cases is more than a physician or more than a surgeon or more than an attorney, without the $500,000 of student loans and the 12 years in school. But realize it's a pretty big thing with a good knowledge, and that's why we have 1,000 hours of training here. Alonzo, you were going to say something.
Yeah, it's funny that you brought that up, Mike. I pulled up the latest Glassdoor, and currently the cloud architect in the United States with 0 or any years of experience is between $153,000 and $270,000, with a median of $202,000. So I pull this up for our students all the time. Number one, to get industry understanding of what the salaries are out there, and 2, to incentivize everyone to do these things, learn the concepts, learn the foundations, take your time. Don't rush into something that you're not prepared for. And it's not enough to get the job. You have to be good enough to keep the job, meaning that you might be able to say all the great things. You might, just like sweet talking someone, you say all the things that they want to hear, but when you get into the relationship, you fumble. You fumble the bag, you fumble the relationship. So we want to make sure that you guys understand and can be comfortable and be able to exercise this and thrive in this environment. So Imagine you being this cloud architect and you're getting $200,000, $202,000 a year. And then there's only one way to go but up. So you got promotions, you got commissions, you got bonuses. So imagine the ideas of not only what you can do in this career trajectory, but the money you can spend on it. So take the time, invest in yourself, invest the time. You'll be where you want to be.
Yeah. And have a career that's going to grow and grow and grow.
Yes. It's a beautiful thing.
Yeah.
So let's see. What's the difference between a global load balancer and a regular load balancer?
Okay, so Steph, there's no such thing as a global load balancer. It's a made-up marketing term, and I'll explain what it is. And then there's a load balancer. So I'm going to start with a real load balancer. A load balancer is either a physical device or a software device that's going to look at the packets coming in and determine where they can go. So what it's doing is it enables you to say load share between 5 firewalls versus a single firewall, or load share between 5 web servers as a single web server. And a load balancer themselves, a real load balancer, is either going to look at, say, the network, what do you call it? So the transport layer of a TCP session, which we call network load balancers, where it's going to look at the TCP source and destination IP address, protocol, and port number. So TCP, port 443, that have you. Now, by comparison, an application load balancer is going to be a very intelligent device, which means it's going to get slowed down. And it's not just going to look at the source and destination and protocol and port number. It's going to start looking in things like an HTTPS header, and it'll see whether there's a push or a get message. So verifyingly, they're usually slow. Now, they are load balancers. Now, a global load balancer is not a load balancer at all. What it is it's using DNS, or the domain name system, to be able to say, hey, send half of your packet to endpoint 1 or half a packet to endpoint 2. And because with DNS, we know where people's source and destinations are, we can say send 50% to 2 different data centers. We can say 50% to 2 different clouds. We could say send half to Azure, half to AWS. And if AWS crashes, I'll go over to Azure, or vice versa. So that's there's a difference between DNS. Now, what happens is many people don't really understand load balancers. They don't understand how load balancers work and how they're looking at the load balancer flows, and whether they're looking at, say, a round robin versus a rated round robin versus a different kind of algorithm you could use. But they know that it sends one thing to most places. So the cloud providers assumed you wouldn't know anything about technology, you wouldn't understand how it works because they don't teach you how it works. And now, poof, the DNS that we've had for the last 50 years is now a global load balancer. So here, Alonzo, I send half of it to your data center and half of it to mine. It's a global load balancer. Now your data center is you're in Katy, Texas. My data center is in Neoptolemus, Greece. Poof, DNS is routing it. And because of that, we can use DNS to say, skip this country, what have you.
Revelation. Is there a target start date for the cloud architect? Cloud development.
Yes, the second you sign up. And here's the reason. The average cloud architect earns approximately $1,000 a day. So if I was crazy enough to do batches and say 6 weeks from now, you can start, realistically speaking, we're dealing with about $1,000 lost per day of earnings. So if I said 6 weeks, that's equivalent to about $30,000 of lost earnings on a 5-day work week for an average paid architect. To me, that seems silly. So the second you sign up for the course, like I've seen some people sign up today. So please, by the way, read the Welcome to Go Cloud Careers email, because I want you to be successful. But for the people that signed up today, poof, they already got a welcome letter. They're already accessing our program, accessing all the on-demand content, being able to access everything. And then they can go to the next class they want. And in our live classes, I'll repeat stuff periodically. So today we're doing an IP video architecture. Maybe 4 months from now in class, we do another IP video architecture. Or this month, we're doing a security architecture. We redo it. And that way, no matter when you're at, you get access to everything. Of course, you always get access to the previous class recordings anyway. And if you're in the live program, you get every class we ever taught. If you're in the non-live program, you get most of the classes we've ever taught, a curated selection, which is still more than you'll ever need. But there's that. But if I want you signed up, and I want you staying in that program until you are hired. That's when I want you to leave the program the day you are hired. I don't want you buying my course. I want you to take our course, buy our course, and change your life and get a great architect job and have generational wealth. That's what I want. So I kind of hope that makes sense. Start the moment you can.
And understand that revelation that the live class, the non-live is without the live classes. The live classes, all of the stuff is standard. You're going to get the asynchronous training, the video content, the presentation assignments, the architectural assignments, the quizzes in between those modules. That is the foundation of it. The live classes on top is what the benefit is of that live classes. So those who do not have the live classes, you can matriculate and add that on at a later date if you so choose.
Yeah. The key here is the live, the non-live, the actual content of the program for the most part is the same. The difference is in the live program, you're in these live classes and you're designing a lot of these in-class architectures with me. Or today you deliver an architecture portion. Or I say, today we're interviewing anybody that wants to practice their interview so they can get hired. And if you're in that live class, I'm going to coach you there. In the non-live program, you get a video of that course and you get to watch it. So you're still getting the same content. It's just, are you watching others do it or are you doing it yourself? Although in both programs, there'll still be projects for you to do, architecture projects.
Do people that pay for the live architect live get access to the, so
absolutely.
You're going to, all the stuff is going to be in a library. So this is what we call a continuous long form development program.
Yeah.
And the reason why we do this is because you do sequential or chronologically with boot camps, because the goal is to you to get certain level of education to clear an exam. We're trying to get you hired into a career that takes iterative efforts, iterative processes. So our live classes are not based off of chapter 1, 2, 3, and 4, like you would do university or something like that. It's all business case minded. We are trying to help you understand how to do the job, how to look at a business case, look at those requirements, find out what's going on in the industry, who's getting hired, why are they getting hired, and what areas are they getting hired. What, like case in point, when Mike illustrated the high demand of security architects and so forth, we're trying to understand the why and what it takes to be a competent, strong architect out there. So we're trying to get you those fundamentals that you need to be successful in the role, not in a certification. I say everything is fading out with the sun, man.
Yeah, you were kind of like, I remember Casper the Friendly Ghost. You were kind of like blue Casper the Friendly Ghost. Sometimes here, sometimes not here.
Yeah. The weather we just got out of a lot of cloudy, rainy weather, so the sun's coming back out. So I think our last questions, we definitely want to say thank you all. You brought in some great questions. We hope you've been edified. We hope you you've gotten the information you need to make a conscious decision to join us at Go Cloud Careers. We have tons of webinars coming our way on a weekly basis and in the weeks to come. We also want to emphasize as well that although we've had a Cyber Week last week, today is our extended time and opportunity and our last time for you to enjoy that 50% off. So we encourage everyone who still is not sure, that we hope that you've made or we've provided the information you need to make a strong decision. And we hope you join us soon.
And for MB Project, you're in a non-live program. You want to sign up to live. Yeah, send an email to info@GoCloudCareers. And they will be able to help you with the upgrade, which is basically just going to be a payment difference. Our goal is always to give you the best and not to charge 2 and 3 weird times. It's not who we are. So I hope you'd enjoyed this discussion on which cloud to learn. And I hope we showed you why you could just get certified and still not know the cloud. And I gave you lots of examples versus learning the cloud and being able to do anything with it and have access to more job opportunities that you want. I do this because I've been interviewing people forever. I've interviewed thousands of people, and I just love hiring people. And I hate it when I can't hire someone in an interview. And sadly, that's most of the time, because I really love telling somebody, look, I've got this big, high-paying job for you. It's going to change your life. It's going to change your family's life. And that's fun for me. Mm-hmm. In any case, if you learned something, had a good time, if you can please give the video a like. If you're not a subscriber, please subscribe and hit the bell to be notified of new videos. We've got so much coming for you this week. I've got people that we trained that are now going to talk about what it's like in their cloud architect world. We've got a VPC security day where we're going to go through the entire VPC on AWS and how you would secure various things. It's going to be fun. We've got a lot of cool stuff, business, executive, and tech. So hope to see you soon. Take care, everyone.
Thanks for joining us. See you soon.